this, or determine the most general antiderivative or the family of functions, in other words. So I'm sure you used x squared plus 1 and du equals 2x dx. So of course, no difficulty in making up a constant ever. So this is 1/2, and the integral is from u to the 5th du, which is 1/2 u to the 6th over 6 plus a constant c, or 1 over 12, and we have to go back to x squared plus 1 to the 6th plus c. That's all we needed here. And on this side, we only wanted to differentiate. So this is g prime, which is tangent x squared times the inner function prime. There is nothing else. Okay. Any questions, please? Anything? Okay, so let's go back in that case and see what else we would like to work on from the indefinite and definite. Do we want to choose anything else or not? Anyone? Anyone?
Can we do number 79?
Yes. 79, perfect. And we have the integral from 0 to 1 from dx over 1 plus the square root of x to the 4th power. Perfect. Let's see what we can do with this one. Not all of them are very straightforward, right? So some of them require some work. We'll see which type this one is. Okay, so what do you think we should do here?
Definitely 1 plus the square root of x.
Good. So now let's see what we can do with the du. So because du could be the problem. So du will be 1 over 2 the square root of x, of course dx. So it's a little bit of an issue, right? Because I don't have a separate the square root of x anywhere here. The 1/2 is not a big deal. But look what happens here if I solve for the square root of x. So if we solve for the square root of x, this becomes u minus 1. I don't like having a u minus 1 in the denominator, but maybe it will not end up in the denominator. So we'll see in a moment. So when we go back, first of all, we have the limits of integration. When x is 0, when x is 0, u is 1. When x is 1, u is 2. dx. So first of all, 1 over u to the 4th. That's very clear. Remember, this can be written as 1 over 1 plus the square root of x to the 4th times dx on the side. Same thing. So then times, I will have to solve for dx, replacing the square root of x by u minus 1. So du now is 1 over 2 u minus 1 dx. In order to solve for dx, so that I can replace it here and put it here, I have to multiply both sides by 2 u minus 1. So then du will be, I'm sorry, dx, I meant to write. dx is 2 u minus 1 du. 2 u minus 1 du. And that's what I have to put up here, or the top, to be more condensed. So this particular problem was perfect pick, but I had to work a little bit harder because I did not have any 1 over the square root of x laying around somewhere. For that reason, I had to use these steps. I had to go through these steps. Number 1, I had to replace the square root of x somehow because I cannot have x and u in the same integral. So I had to get rid of this somehow. No problem. I move 1 to the other side, so the square root of x is u minus 1. So this piece was u minus 1. The 2 stays, u minus 1 is here, dx is dx du. So then now I'm solving. Here I have no choice. I have to solve for dx, multiplying both sides by 2 u minus 1. So then dx is 2 u minus 1 du. So I replaced this by this. Any questions before we continue? It's not done, of course. Any questions? Okay. So 2 goes outside, the integral from 1 to 2, and now as we did before, twice today, u minus 1 over u to the 4th will be u over u to the 4th is 1 over u to the 3rd, and minus 1 over u to the 4th du. Because we have u over u to the 4th, we simplify 1u, but this one stays as is. I don't like this the way it is presented, so I have the integral from 1 to 2, u to negative 3 minus u to negative 4 du. This is much better for integration. So then I have 2, u to negative 3 plus 1, u to negative 2 over negative 2, minus u to negative 3 over negative 3 from 1 to 2. I'm going to simplify it a little further. So 2, negative 1 over 2 u squared, and plus 1 over 3 u cubed from 1 to 2. So here's what I did. I brought this to the denominator, and I have negative 1 and 2, right? Negative 1/2 u squared. I have 2 negatives here, so this becomes positive. I bring this to the denominator, so 3u to the 3rd. Now I have to apply FTC. At this moment, FTC. I plug in 2 everywhere, and then I subtract when I plug in 1. Leave the 2 outside, do not distribute it till the very end, or just leave it alone for good. So 2 to the 4, 2 squared is 4, 4 times 2 is 8. Plus, so this is 8 times 3, 24. But now minus, be careful for both of them. It's better to put parentheses so you don't forget to distribute the negative sign. So when I plug in 1, I have negative 1/2. When I plug in 1, I have positive 1/3. So finally, 2. Negative 1 over 8 plus 1 over 24 plus 1 over 2 minus 1/3. So obviously the least common denominator is 24. So now let's see the adjustments. What are the adjustments here? So here a 3, here a 1, here a 12, and here an 8. Negative 3 plus 1 plus 12 minus 8. 13, right? 13 minus 11. So I'll simplify. Again, I have 13 minus 11, which is 2. So it's 1/6. Any questions on this problem? This was not a trivial problem. This was a little bit more sophisticated. It required more steps. It required us to, it was not as easy as this one, right? I just need an adjustment of a factor of 2 and it's done. No, this one needed us to discover and determine dx. Again, so please do not copy 2 u minus 1 over u to the 4th and then dx. That would be terrible. You cannot have 2 variables in the same integral. When I move from x, I completely move from x to u. Any steps that you want me to go back to, or steps? That you, yes.
How did you get the second integral again? The 1 to 2 instead of the original, which was 0 to 1?
When x is 0, u is 1. When x is 1, u is 2.
Okay.
Perfect. Other questions here? Anything else? Anything else? Anything else? Okay, so let's see if you want to see anything else. Again, you're not asking anything from Web Assign, so then you're going to have to work on it on your own. So I didn't want that, but what can I say? Are we okay with this? We only have to look at one more theorem, which is called the net change theorem. And that's the end of the course. And I do have one other thing to show you. So anyone would like to choose anything else?
Yeah, can we do 80 as well?
Yes. This one?
Yes.
So let's look at 80. This is the integral from 1 to 16, x to 1/2, 1 plus x to 3/4 dx. Good, interesting. Now, this is an even slightly higher level than the previous one. Here's why. I don't know what I'm going to get. I'm going to start by saying, okay, let u be 1 plus x to 3/4. I don't know exactly where I'm getting, where I'm going to end, so we'll have to see. As I said, some situations are very clear, some are a little ambiguous, and others are more involving. Good, so du will be 3/4 x to 3/4 minus 1, which is, what is it, negative 1/4. So we bring down 3, we subtract 1 from the power, 3/4 minus 1. I'm checking my numbers, negative 1/4, correct, dx. Well, I have an issue here, right? So I'm getting an x to negative 1/4, and the question is, how do I get that? Okay, so let's see how we get that. So du will be 3/4 the 4th root of x dx. Okay. Okay, so what is this? This will be, this squared is that. I see. So what I already noticed is that the 4th root of x squared will be the square root of x. This is what we have here. X to 1/2 or the square root of x is the same thing. So we'll see what happens. I have no idea yet. I don't see it yet. Hopefully we get there. Okay, so I have the integral from when x is 1, 1 to 3/4 is 1, 1 plus 1 is 2. 16. The 4th root of 16 is 2. 2 to the 3rd is 8. 8 plus 1 is 9. I do have the denominator, which is u. I do have dx, which is 4, the 4th root, 4/3, the 4th root of x du. So I multiplied both sides by 4, the 4th root of x, and also divided by 3. I cannot write this in here because I cannot have x. So I have to get the 4th root of x somehow from here, because otherwise I can't continue. So I'm going to leave this alone and then come back to it. So u equals 1 plus the fourth root of x to the third. So u minus 1 equals the fourth root of x to the third. Fine. This is the same with u minus 1 equals the fourth root of x to the third. So that's the same thing. And remember, we have here the square root. So the top is the square root. So we have the square root. Let me see, maybe I should have simplified somehow a little bit if I can. The square root of x 1 plus the fourth root of x to the third. So this is the same with the fourth root of x squared. And this is 1 plus the fourth root of x to the third. Okay. So that's correct, that's correct. Okay, let's see what we have here. We have the fourth root of x to, so 4/3. I need to get this out of the way somehow, and times du. But I cannot put the fourth root. I'm going to write it like this, but I'm going to erase it. So I cannot put this in here because I have two variables in the same problem, and that's not allowed. So I only have to come up with the square root of the fourth root of x somehow in terms of u. So, okay, so from here, I have u minus 1 equals the fourth root of x to the third. I only have to take the cube root of u minus 1, so that will be the fourth root of x. So then in here, I will have the cube root of u minus 1. I'll have to let it dry. I should have not written anything in there. So we were able to get from the substitution u minus 1 equals the fourth root of x to the third. And the fourth root of x to the third is the same with the fourth root of x, everything to the third. So when we take the cube root from both sides, we get the fourth root of x that I needed. So this is the cube root of u minus 1. Yep, I expected that to happen. So any questions so far? Because this is not done, of course. So we only managed to change everything from x. And this is more difficult because it has two terms in the denominator. And this is hopefully easier because we have the cube root of u minus 1 over u. And I'm still thinking that I should have simplified here somehow. I think that that is a better deal, because now I am stuck with the cube root of u minus 1 divided by u. So I have to go back to the function and see how I can manipulate this to make it work better, because what I'm getting here, it's okay, but it's not helping with any other substitution right now. So I have to go back to the drawing board. And the drawing board was this. This is a very interesting problem. Let me see my time.